Hi everyone, you are welcome to my YouTube channel, and for today I'll be showing you how to design a pad foundation using STAAD RCDC. We've done the beam, we've done the slab, we've done for column, and now we are moving to footing. So as usual, you type the name. Let's give it footing design, and then the client, that is YouTube viewers, and the engineer, that is me, which is Ridwan Tishan. And then just pick the name, pick the file. So the file, gift house, then open. So footing, then create new project. Okay, so it's going to show us the column points. Okay, so these are the column points. You can see we have column 1 to I think column 24. Okay, yeah, column 24. So these are the column points. So we are going to design a base for all these column. Understand? We're going to design a footing for them. So let's go about that. So this is column 1. So the footing of this will be called footing for column 1. So you see FC1. All right, so you can see that's how it labels it. Column mark, the column mark is column 1, then the footing will now be FC1. But you can decide to rename it. You can decide to name it as F1 instead of FC1. You can name this F2, name this F3. Let me just decide to leave it as it is. All right, let's leave it as it is, FC2, because it is even wasting of time to FC1. We have about 4 different kind of footing here. So if you click on this drop down, you see we have a pad footing, you have a sloped footing, you have a stepped footing, and you have unwrapped footing. All right, so let's just pick the pad footing, and let me pick the sloped footing. Yeah, let me put the sloped footing. Then the column offset, let's say the column offset is 50. So let me just copy this, and then I'll paste it for all of this. I'll paste it for all of this. Okay, so all of this, there will be sloped footing, and then the offset from the column will be 50. All right, so you can't change anything here, because even if you try to insert any figure, you won't be able to insert, because you are not using you can see raft thickness. We are not using unwrapped type. You understand? If you look at this is unwrapped. If you pick unwrapped, that is when you'll be able to change this. All right, so that is that. Okay, so after you are done doing that, you come to settings, then you go to general settings. All right, so under the general setting, you should change this if you want, but I would prefer to put it in C30. The steel grade, I'll put it in C10 and F10. Then the cover for the foundation, let's use 40. Then the reduction is 0%. Then type of soil, if it is a rocky or hard soil, if it is a medium or soft, let's just put it in medium. All right, then what else can you change here? The depth round-off, put it in 25. The plan round-off, you can put that in 25 if you want. You can put it in 50. That does not really matter actually. So then you also have to change this SBC, that's your soil bearing capacity. All right, so that's your net soil bearing capacity. My soil bearing capacity is not 200. Let me assume it is 120 kilonewton per meter squared. So you change it here. All right, then provide face reinforcement. No, I do not want to provide. Then surcharge load, you know what surcharge is? That is the load that is placed on the soil that is on the base. So the load caused by the surcharge, if you want to add all of those, so you can go about doing that. So that's all. So I will just click on OK. You can still come to reinforcement settings. This is where you set your reinforcement, the minimum bottom by 0.13%. That's 0.13% of the section. That is 0.13% BH multiplied by B multiplied by H, right? Then the minimum points, let's leave it as that, so 0.13%. all right, and then you change the dimension for the rebar. The main steel, the minimum, let the minimum be 12, and then the minimum for the top steel too, let that be 12, then let the maximum be 20. Yeah, so the shear, that is when you have the link, let it be 10, then let the maximum be I'm sorry, 12. Okay, then the side face reinforcement, that's the skin reinforcement. So let the minimum be 10. Yeah, let the maximum be 16. Okay, So I think everything is selected here. So your space round of spacing, the round off of your spacing, put it in 25. Your maximum shear steel, all of this, you can leave it as it is. Okay, so click on OK. When you're done with that, you can also come to detail drawing. You can change this face reinforcement there. Where's this? The lap length, yeah, the lap length of your face reinforcement, that's 300. If you want to increase it, you may use about, but this 300 is not bad. All right, so your rebar back manager, um change this to Y, and then use iPhone for here, and then I think that's good enough. You do the same thing for shear, change this to Y, change this to at, you understand, then you see how it will be, you understand. 4 legs, Y10, Y20 spacing, center to center. Do the same thing for your skin reinforcement. So this, change it to Y. All right, so and then you are good to go. So you click on OK, and then OK. So the drawing scale, let's say you want to use 1:25 or 1:50, but just within 1:25. I prefer 1:25. Okay, so you click on OK. Then you come to basic load cases. Then the first one, which is load 1 dead, this is dead load. The self weight, that's dead load. These are the loads from the analysis. Okay, so if you are, in case you don't know how this load got here, these load are the load I used in the analysis when I was doing the analysis from STAAD Pro. So okay, then for your design, you click on add from analysis. Then you're going to see how I've factored it from STAAD Pro. Then you go to sizing, do the same thing, and then soil bearing capacity, you say buoyancy, sliding, you can design it for everything. Then you click on OK. Then you click on design, so you allow it to do design. Okay, so now it has completed the design. All right, so you can see from this point, you see you have the FC1, you can see the footing is there already. So you can see this is bigger than that, this is bigger than this. So but you can properly check it here. You can see 230 by 230, that's the column. Then look at the dimension, that's 150 by 150 by 300. 300 is the thickness. 300 is the thickness of everything. So I think we only have few of them that are different. This one 1950, this one 2000 by 2000. Okay, now so since you have everything, you can go ahead to check your detailed drawing. Understand, you can check your detailed drawing. Let's say you want to see for footing 1, you want to see the plan, and then let's say you want to see a section at L, section at B, and click on OK. Okay, so this is it. So if you look at it very closely, you see this is the footing. You can see the thickness of the footing is 300, and then the width, that is 1150. You see you have a blinding of about 150 mm thick, that is PCC, which is plain concrete. All right, so you have your blinding, and then you have your rebar. You can see the design of you can see the detail of the rebar. You have your top U, and then you have the bottom U, and then you have the members. All right, so this is it. So the member is Y12. Also this one is Y12. So everything is Y12. You can see it's just the spacing that differs. So you can see Y12 300 cc top, Y12 300 center to center bottom. So it will go ahead to do the lapping. So you can see you have your lapping length here, which is LD, and then you see it names you can see the link. So you have your link here, so you can see column link, and then this is bottom of floor, bottom of footing, sorry. So this is bottom of footing. BOF simply means bottom of footing. This is elevation 0. All right, so this is the elevation 0, bottom of footing. So that is how it is. Then you can see section 2.2. This is section 1.1, right? And then this is section 2.2. You can take a section at both sides. It is a square footing. This is a square footing. The first section is 1150, and the second section too is 1150. So that tells you that it is a square footing. It's not that you have 1150 at this side, then the other side is giving you a different one. All right, so but how do you know the section that is 11 and the section that is 22? That is not difficult. You can come to the plan section. So come to the plan section. This is your column. All right, this is your column point, and this is your footing point. All right, this is the reinforcement. So you can see from here to here, that's your footing. You can see it is 1150. All right, then the surrounding block here, this surrounding dash line, it represents the PCC. You can see it, 150 thick PCC. All right, so the X section, that is section 11, and the Y section, that is section 22. So this is section 11 that you are seeing here, and this is section 22 that you are seeing here. All right, so that is all for the footing design. So you can see the whole footing layout. You can see the whole footing layout here. All right, so that is that. So you can as well check the plan detail. You can see this is the plan detail of the design. You can see your reinforcement here. So that is what Y12 by 300. You can see Y12 by 300 center to center bottom. You can see it. So just check through. So that is all on footing design. You can check more, text schedule here. You can do text schedule in vertical. Okay, I think it looks more better in vertical. So when you see your footing one, you understand the footing one, the column number is C1. Then the kind of footing we are using is SPAAD. All right, so the step, so the L, the B, the L, that's the length, the B is the breadth. Then this is the thickness, which is what, 300. Because it is not a sloped, we don't step one side. One step is not higher than the other, so D1 is definitely the same thing as D2. All right, so along B is going to tell you how you dimension it along the B, along the L. B is the breadth and L is the length. All right, so it's going to tell you, okay, you have Y12 at 300. This is basically the text schedule, you understand? So you can check more. You can you can do your bar bending schedule, BBS, that's your bar bending schedule. You can do a lot of things. You can even check your what's it called, your design calculation, and then more stuff like that. Thanks for watching, and make sure you stay tuned for my next video. If you've not subscribed, ensure you subscribe, and if there's any question, don't hesitate to drop it in the comment box. Thank you for watching.